The average atomic mass of element A is 63.6 atomic mass units. The only naturally occurring isotopes are 63 and 65. What is the percent abundance of 63 in naturally occurring sample of element A to the nearest whole number percentage? Well, this is going to involve doing the same thing that we did on the previous question, but backwards. It's a little more difficult. But we know that some fraction x times 63 plus 1 minus x, which is the other part, times 65 is equal to 63.6. If we distribute this out, we end up with 65 plus 63x minus 65x equals 63.6. 65 minus 2x equals 63.6. Subtract 65 from both sides, and we have 2x minus 2x is equal to minus, this is 1.4. I'm doing this in my head. We can change the sign on both sides without it raising any complications, and x ends up being 0.7. So this x right here is 0.7, which is the same thing as 70%. So element A is 70% A63, and the remaining 30% A65. They ask us what the percent abundance of A63 is. Whole number percentage was 70%, so on my bubble sheet I would have just bubbled in 70, or 70 point. It did say whole number percentage, so we don't need to put in any of this stuff after. 37. What is an intensive property of a sample of water? Intensive means it's fundamental to water itself and not to how much there is. How much we have affects the mass, and how much we have also affects the volume. How much we have affects the number of moles, but the molar mass of water is the molar mass of water no matter how much we have. So that would be an intensive property. The others, all of these others, are extensive. How are theories different from hypotheses? A theory has been tested and is accepted as an accurate explanation, while a hypothesis is just a prediction. It's actually the correct answer. Let's look at the rest of these. A hypothesis can be changed while theories cannot be changed. This right here is incorrect. Theories are not always correct. We revise them all the time. A theory explains why a scientific law occurs, while a hypothesis explains how common phenomena occur. Theories and hypotheses can explain either one of those things. A theory has supporting test data. A hypothesis is an educated guess, while a theory is an explanation for common everyday experiments. While you might arguably say that a theory or a hypothesis is an educated guess, a theory is not just an explanation for everyday experiments. A theory has been tested. That is the most important part of this. Number 39. A student inflates a balloon. They measure the size of the balloon. Then they place the balloon in the freezer for 2 hours. Students remove the balloon and measure its size again. Which characteristics of the gas are variables in this experiment? Since they're measuring the size of the balloon, we could imagine that they are measuring the volume. But the amount of gas doesn't change, so it can't be this. Again, we see volume, and we put it in the freezer, so temperature makes sense. The pressure of the gas, I guess we can certainly measure that, but we know that the amount of gas doesn't change. And lastly, the temperature and the pressure of the gas. Again, both of these can be measured, but what are they actually measuring? They measure its size. So the key thing is volume here. Can't be this one, so it must be this one. The answer is B. We're in the home stretch. Which particle diagram represents a mixture of element X and element Z only? Element X is this circle, and element Z is the open circle. Where do we see a mixture of the two? Well, in this case, they're not bonded together. This must be a mixture. In this case, we see a compound of X and Z, and also some free X and Z. In this case, we see several different compounds of X and Z. And in this case, we see a pure compound of X and Z. But only in this case do we see a mixture of just element X and element Z only. So the correct answer is F. Which sample of matter is a single substance? Well, hydrochloric acid in solution means it's a mixture of hydrochloric acid and water, two substances. Salt water, again, salt and water, two substances. Air is a mixture of gases. So the answer must be D, ammonia gas. An atom of an element has a total of 12 electrons. An ion of the same element has a total of 10 electrons. Which statement describes the charge and radius of the ion? Well, if the element has 12, but it lost 2, then it's going to have a positive 2 charge. So we can get rid of any of these questions that talk about negatively charged ions. And that leaves us with just these two. The last thing that we need to know is that if an element loses its outer electrons, however many they may be, then one of these shells disappears and the element shrinks. It also shrinks because the nucleus of the atom attracts the electrons closer. So the radius of a positively charged ion is always smaller than the atom. So we have positively charged, and the radius is smaller than that of the atom. The answer is G. Which property is characteristics of nonmetals? They lose electrons easily is incorrect. This is a property of metals. They are good conductors of electricity. Again, this is a property of metals. Low first ionization energy means that it takes a small amount of energy for them to lose electrons, like this one. Again, a property of metals. High electronegativity. That is true. Nonmetals have a high electronegativity. They like to grab onto electrons and hold them. That's why most of them, or all of them in ionic compounds, have negative charges.